Hi everyone, in this video I want to talk about graphing quadratic functions in vertex form. Here are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question. How many countries would you like to see before you turn 90 years old? So on the math section, you will see quadratics in some shape or form, I'm sure. Algebra 1, we would count that quadratics as, but it's possible that you would see graphs. And so this video would help you graph a quadratic that's written in this sort of format. So let's talk about the three possible forms: standard form and intercept or factored form are the other two possibilities. So what I love about vertex form here is the vertex of the parabola. Quadratics give you a parabola. The vertex is typically the most important part to figure out so that you can graph it from there. So for this first problem, I can tell right away what the vertex is based on the looks of the problem. So vertex form is, f of x or y equals, and then it goes a, so a number up in front of the parentheses, then x, and then it's minus h squared plus k. Now that hk is the actual vertex. So that's why, well, as long as you remember the h, there's a minus in front of it, you can just size up the problems pretty quickly. Let's say this was multiple choice and you were asked what the vertex was. As long as you know vertex form, you can do this fast. So this right here, the a would be -1. The h is also -1. And the k is -6. Okay, so let's write that on top. A x minus h squared plus k. Let's make sure you agree that the hk would be, the vertex, would be -1 and then -6. Okay, so the a then is -1. And what does that tell me? Well, if the a is greater than 0, meaning positive, then the graph is going to point upwards, the parabola. If a is less than 0, it will be downwards. So I know the first problem will be pointing down, and I'm just checking to make sure I have everything right. So yeah, I can plot that -1 and -6, and that's right here. Now this graph is going to be pointing downwards, right? Because the a is -1. So I know that the graph is going to look, it could be skinny like this. It could be a little wider. It could be super wide. We just don't know exactly what the rest of it looks like, although we know it starts there, and that vertex would be a maximum. So now I need some other point to graph, and that other point that I recommend is the y-intercept. And that is when you set x equal to 0 and solve for y. So if I set x or the y equal, x equal to 0 and solve for y, think of f of x, remember, like y. And I have this -1, but then I have 0 plus 1 squared minus 6. Now let me solve for that. So -1 times 1 squared minus 6, that would give me a -7. So I know that my other point is the y-intercept, and that is at -7. So if I have one other point other than the vertex, like I do know that I can draw this graph. Why? Because I know that if this is the vertex, then this graph is going to fall and cut through that -7. And then it also has symmetry, you know, like the axis of symmetry goes right through the vertex. So I can graph another point, and that is right here. And there you have it. That's the graph, because I know that whatever you have on one side, you will have on the other, just as a mirror image. Now let's try the next one. In this case, the A is 3, that's positive. So it's going to be pointing upwards. And I know that by looking at these two numbers, I can figure out my vertex. To really make sure I don't mess up any negatives, I love writing out the formula on top, x minus h squared, and then plus k. See, that's where people go wrong, is they'll forget little negatives. So you can see right here the h is just positive 2, but then the k is negative 4. So I'm going to say my hk is 2, comma, and then negative 4. Think about if that makes sense. And then, so let me graph that, 2, negative 4. And then my y-intercept is going to be, y or f of x equals, and then this will be 3 times 0 minus 2 squared minus 4 equals 3 times negative 2 squared minus 4. I have to be really careful here that I do order of operations. So that's 3 times a positive 4 minus 4, and that would give me 12 minus 4 is 8. So the y-intercept is all the way up here at the 8. So remember which is which, though. This is another commonly missed error where which is the vertex? The vertex is this 2, negative 4. So I know that my graph is pointing upwards, first of all, and it's going to cut through that y-intercept. So whatever I see on one side, I see to the other side. So like, come up here, go to the right 2 units now, and there's the rest of the graph. So try some practice. These problems are very similar. We have, a shifted graph here. If you want to also use the parent function information, this might be pretty quick for you. If not, use the vertex form. There are so many different ways to graph these. And then this one has not only a fraction in the front, but a negative. So think about, how that might affect the graph. You can pause the video, work on these, and then I will reveal the answers. Okay, answers are here. So we know the first one's pointing upwards. We know the vertex based on the formula. And then this one's pointing downwards because it's negative. And there's the vertex, negative 5, 2. All right, a quote to leave you. Some inspiration. Obstacles are those frightful things you see when you take your eyes off your goal. That is a great thing to remember. And I hope this video helped you in some way. Feel free to leave your answer to the fun question in the comments, and you can subscribe if you'd like to keep up with videos. Thank you.